Linux can read and write to X4, XFS, BTRFs, NFS, and dozens more file systems, all with the same commands. But how does the kernel manage that without going insane? The answer is VFS, the virtual file system, and it's one of the most elegant designs hiding inside the Linux kernel. VFS sits between your applications and the actual file system code. It defines a set of generic operations: open, read, write, close, set. And every file system that wants to work with Linux must implement those operations. Think of it like a contract. The kernel says, here's what I need you to handle, and each file system plugs in its own version. That's why you can run the same cat command on an X4 drive, an NFS share, or even a virtual file system like proc, and it just works. Here's how it fits together. Your application makes a system call, say open or read. That call passes through the system call layer to VFS, which doesn't know or care what file system sits underneath. VFS looks up the path, figures out which file system owns it, and delegates to the right driver. X4, XFS, NFS, they each handle the request in their own way, but they all talk to VFS through the same interface. The application never sees the difference. VFS works with 4 core data structures to represent any file system. The super block represents an entire mounted file system. It holds things like block size and type. An inode stores metadata for a single file: permissions, ownership, timestamps, where the data lives on disk. Dentry, short for directory entry, is the glue that maps a file name to its inode. It's what lets VFS walk a path like homelessreport.pdf piece by piece. And the file object is what you get back from an open call, a handle that tracks your read position and access flags. These 4 structures give VFS a universal language for any file system without knowing the implementation details. Let's trace what happens when your program calls open on tmpdata.txt. VFS starts at the root dentry and walks the path one component at a time. First TMP, then data.txt. For each piece, it checks the dentry cache to see if that lookup has been done recently. If not, it asks the owning file system to find the inode. Once VFS has the inode, it calls the file system's own open method, which might do permission checks or update access times. Then it creates a file object and hands it back to your application. All of this happens in a fraction of a millisecond. This abstraction pays off in ways you might not expect. Because every file system plugs into the same interface, you can add brand new ones without changing any user space tools at all. Fuse lets you write a file system in Python or Go, running entirely in user space, and mount it like any other drive. Virtual file systems like procfs and sysfs expose kernel internals as regular files. That's how tools like top and LSQ actually get their data. Network file systems like NFS and SMB just show up as normal directories. One set of commands, every file system you can think of. VFS is the reason Linux's file system story is so flexible and consistent. Next time you run ls or mount a drive, remember there's a whole abstraction layer quietly making it work. Thanks for watching Awesome Linux TV. Bye-bye.